For this video is going to be continuous from what we have learned in class. We're going to start from protections and security until the end of the module 1. Later in class, we're going to continue with our module 2. Okay. So first of all, related to protections and security, it is not only in terms of computer, it is in our daily life also. Protections and security is the main issues. So we always referring something that more secure, similar also to our computer and also OS operating system. So in terms of protection, this is the definitions of protection, which is a mechanism for controlling access of processes or even a user to resources defined by the OS. In terms of security, a defense system again internal or external attack. Normally our computer have like what we can call firewall for us to prevent any external or internal attack, isn't it? So that is in terms of security. And then in terms of security, it can be huge in range, including denials of service, I think this one is really familiar with all of you. Mine also, when I am a student, we always like need antivirus. We have a Trojan last time, and a small worm, it's also going to affect our files and also application. So identity thief of service and etc. Later on, when you go to like a cyber securities that you're going to learn on, there are several type of thief. It depends on how big or might be professional terms in terms of themselves. Okay, system generally first distinguish among other users to determine who can do what. So sometime in your computer, in one computer, we can have several users, isn't it? So you can see among users. First is user identities, which is user ID related to your username, your password, which we call as user ID. We can call it also as authentications. So including name, associate numbers, user. Currently, we can have a lot of like implementation in terms of authentications. I don't know about a computer. Normally computer and laptop are using username and also a password, but if you look into like your phone, we have also OS, isn't it? All the phone also having a their own OS operating system. So they have several authentications, which is like using passcode, biometric. Okay. Even a laptop currently, we have also biometric, isn't it? Using a fingerprints. So that is on in terms of user identities. User ID is associated with all files and processes of the user to determine access control. Group identifier, okay, this one also you can explore in your control panel. You can group all the users, which file that they can explore or use or access. You can see under your control manager, it can also be group following the application. Sometimes the application cannot be accessed because of the group setting, isn't it? So privilege escalations allow user to change the effective ID with more rights. Okay. Process management. A process is a program in education. So it is a unit of work within the system. Program is a passive entity, which is a process is active entity. So you have program as a passive entity, while the process is a active entity. You need to know the differentiation between these two. Process need resources to accomplish its task, which is like CPU, your memory, input output, the file itself, and also initializing data. So most of this you already learned in your COA subject, and it is related to process. And process termination require reclaim of any reusable resources. Single threaded process has one program counter specifying locations of next instruction to execute. So example is a process executes instruction sequentially, one at a time until they complete. Okay. So multi-threaded process, sometimes we can have several process in time, which is we call as a parallel. That's why later on you're going to learn on parallelism in your computer. Has one program counter per thread. Typically, system has many processes. You can see here you have a lot of processes. Some operating system running concurrently on one or more CPU. This one is normal for us, isn't it? Concurrent by multiplying the CPU among the processors or even a thread. Okay, what activities occur in terms of your process management? So there are several activities, which is first creating and deleting both user and also system process, suspending and resume process, providing mechanism or even for your process synchronization, providing mechanism for your communication, and providing mechanism for your deadlock handling. Okay, so this is the process management activities. Next, what we're going to go through in terms of the theory is related to your memory management. Okay, last time you have been introduced with a lot of information related to your memory. You have RAM, you have ROM, you have several other type of memory that can that available in terms of your computing system. All data in memory before or after processing. So you have a lot of data that you're going to use. Sometimes it's already been stored, but after you process also it can be occur. All instruction in memory in order to execute. So you're going to store it first in your memory. Sometimes you need it and you're going to call whatever inside your memory before you can like execute, before you can play anything that you want to. So example, what you can store in your memory, which is your application. Let's say you store Microsoft Word in your memory. So it's just waiting any instruction to be done to execute and to open or run your application. Memory management determine what is in your memory, which is when optimizing CPU utilization and computer response to a user. So if you need to know more in terms of the memory management, there is several activities like example, keep track of which parts of memory are currently being used and by whom. So you can check it in terms of at your memory management activities. Sometimes it is needed also because sometimes you can't realize that at the back of your system there is several applications that run in behind. So maybe you can try to track them, isn't it? So deciding which processes or part and data to move into or out of memory. So I don't know whether you are always doing that, but for me myself, I think like every month I need to do because my notebook or laptop having a small of amount of RAM, and also the storage also quite small, so a lot of process like deleting, moving all my documents are needed. Okay, allocating and deallocating memory space are needed. If let's say you are dealing with last time I mentions about divided, isn't it? You can divide your partition, so you can do allocation, deal with your location memory space. Similar also when you are installing your virtual machines, virtual box, you can see that some you need some space just for your virtual machine, isn't it? Especially when you want to install Fedora, there is several amount space that you need. So in terms of the RAM and memory also, you need to allocate for them. That's why this is some of the process on the memory management. Okay, next in terms of storage management, this is not a new terms for you, especially you just having a fresh mind on the COA subject. You can have several type of storage, isn't it? So OS provide uniform logical view of information storage, abstract physical properties to local logical storage unit, which is similar to the file. All the files that are organized in your computer, in your laptop. Each medium is controlled by the device because there is a lot of type of your storage. You can have the disk drive, you can have the tape drive. What else you can have? All that you have been through in your COE, that is your sometimes the medium for the storage. Okay, and you are the one that control it. Might be you want to remove it from your computer, might be you want to insert it, or might be you going to search to install. So it is all controlled by the device. File system management. Okay, instead of file system management, maybe you can try to Google how the file system management look like at your computer. File usually organized into directories. That's why when you are playing around with Linux later on, if you want to search, it is not like clicking, but in terms of you can use your terminal to find your file or any application through their directory. If you know the directory, then you can like open and etc. So all is organized, your file are organized into the directory. Access control and more system to determine who can access what. Okay, this one is also quite similar to your security last time from your previous slide. Okay, OS activities. What is example of OS activities including the storage? Okay, example is creating and deleting file, in your computer, of course. Primitive to manipulate files, mapping files onto secondary storage. This is like maybe you can do a copy paste. Sometime in terms of Linux itself, you can just point it out to the directory and you can paste backup file onto the stable non-volatile storage device. Storage media. Okay, this one is also under a storage. Under a storage, you can have the mass storage management. Okay, usually this used to store data that does not fit in a main memory, data that must be kept for a long period of time. Okay, if you remember this, what is the type of the storage? Property management is of a central importance. Entire speed of computer operation on this subsystem and its algorithm. OS activities like dealing with the mass storage, which is when you heard about mass, it's quite huge, isn't it? So huge storage that needed. Free space management is also quite similar to here, which is the normal storage activities, creating and deleting. Storage allocation is also similar when you want to have divisions like allocating and also delocating your systems, files and application. And this scheduling it's personally I rarely use this. I rarely do this scheduling. Okay, maybe you can try to do it and maybe you can explore how to do it. Okay, so some storage need not to be fast. Okay, so there is several storage, including the territorial storage, includes optical storage, magnetic tag, and then it can still also must be managed by your OS or the applicants itself, like your computer or devices, your own machines. Varies between warm, which is write once, and maybe it can be also read many, which is you can read many times. And RW refer to the RW, read write. Last time when I learned about this, normally I'm referring to the CD. We don't have, or it is really hard for us to have like pen drive, because last time it's quite expensive. That's why like CD is the optional for us. Especially we're going to buy the writable CD, so we can write and then we can delete, we can write and delete. With that types, I need to know the name, how the name is spelled and so on the disc. So then it helped me not to buy write only. Okay, write only, so I cannot rewrite it, so it's going to be quite expensive for me if I just buy one time and then I dump it and then I need to buy another, isn't it? So in terms of name, it's also important for us, especially when we want to buy something for our own use. Okay, in terms of performance of various level of storage, you can see we have several level, 1 2 3 4 5 level altogether. So example, last time in your COA you learn on register. If you still remember your hierarchy of your pyramid, please refer it back. There are several level for your storage, which is more near to your CPU. It's much more faster, isn't it? So first of all, level 1 is register, second is cache, third is memory, fourth is solid state disk, and 5 is magnetic disk. I don't know whether it is similar to your last pyramid or not, but here you need to know in terms of size. You can see how big it is comparing to others. Okay, register only have fewer, which is less than 1 kilobyte, which is in terms of storage. Cache is much more bigger, but it's still in terms of megabyte, you can see here, and etc. So what type of technology, how many time is needed to be accessed? So you can see it's going to be much more higher in time when you are move towards the level by level. Similar also to your pyramid. If you want to draw your own pyramids, it's also okay for you, especially if you want to memorize it. Sometimes people, there is several people that familiar with picture, or okay for them to study in terms of a picture, comparing on the tables like this. So it's depend on you, but you need to remember all the features following the performance of each levels. Okay, next is migrations of integer A from disk to register. So when you have examples of integer A, you want to move from your disk to register. What is happening? So you can see from this to your register. So it's going to be here. You're going to go back to the lowest level, which is level 1. From your magnetic disk, you go and pass it to your main memory. Okay, this one is also quite similar because this will be direct to here, because normally magnetic disk is external storage, isn't it? Then it goes to the main memory. After that, it will pass to the cache, and cache lastly will pass to the register. So hardware register. Multitasking environment must be careful to use most recent value, no matter where it is stored in the storage hierarchy. Multiprocessor environments must provide cache coherency in hardware, such as all CPU have the most recent value in their cache. This one, when you are playing around with assembly language, you can try to check what is the latest value in your cache, isn't it? Distributed environment situation even more complex, like several copy of data can exist. Various solution will be covered in chapter. I think this one is wrong. Okay, input output subsystem. One purpose of OS is to hide in terms of, okay, for input output subsystem, you know already about input output. So what sometimes you will think that it is not necessary for you to have this input. It is not necessary for you to have this type of devices for the output, but especially for your system, computer system, you need to have all the 4 elements: input, output, process, and storage. So this is another important things that you need to know. Okay, one purpose of OS, which is your system, is to hide peculiarities of hardware devices from the user. Input-output system responsible for memory management of your input-output, including buffering when you are dealing with the storage data temporarily while it is being transferred. Caching storage part of data is faster storage for the performance. Spooling the overlapping of output of one job with input of other's job. And second, when you have general device driver interface, lastly driver for specific hardware device. So this is the responsible, several type of responsible for your input-output subsystem. Okay, we move to next, which is type of operating system. Okay, normally we're going to move one by one. We look into the early system, which is before this there is no operating system. Last time I mentioned to you that might be you can come out with a new computer which is without operating system, but last time it's already have. Only might be you can in term of you can improve in term of the way it more like might be more organized. So who knows, might be later on we no need for us to use operating system anymore. But this is the early system. Machine run from a console with display light, toggle switch, input device, and printer. Programmer act as a operator, which is set up including loading the compiler, source program, saving compiled program, loading, and linking to each others in terms of your system. And normally a early system, last time the previous one, we have one user system only, and it is serial processing. Comparing to ours currently, it is a parallel processing. Okay, so the weakness or disadvantages is the CPU idle is going to waste your CPU time, and also in terms of the processing. Okay, there is several categories of computer operating system. First is bash, and then interactive, real-time, hybrid, and lastly embedded. You need to remember in terms of these 5 category. Sometimes in question in your test, it's not going to mention that there are 5 altogether. So you need to know the first key is 5, then you need to remember all the categories. 2 distinguishing features: response time and how data enter into the system. Okay, for bash system, you can see here this is quite similar picture. Sorry, this is quite similar picture in the OS slide last time. If you still remember what is the function all of this, so it's like a dotted. I don't know what is the hole in the paper here. It look like this. Maybe the computer will recognize it in terms of this row. might be in terms of this ledger here. So you need to know that this is example of your bash system, which is input relies on the punch card of tab. Similar also like last time when we have a bus ticket, we didn't have a printer, but we have a punch. So there is a conduct I can't remember the name. He will punch the ticket just to check whether that you just buy the ticket and then you cannot reuse anymore. So some jobs are collected and executed as one batch, which is reduced setup time. Resident monitor or batch monitor is introduced like first of all, or maybe in terms of the basic operating system. So when these batch system are known, this is the first time or maybe the first basic operating system that created. So initial control is the monitor itself. It's going to control the transfer to job. When job completes, control transfer back to the monitor. So the main things which is that control, initial control, which is your monitor, then it's going to go to the control transfer to the job and then after complete doing that, it's going to transfer back to the monitor. Use automatic jobs sequencing, automatically transfer control from one job to another. Okay, after that, from here, from the early system, and then we have the batch system, we move to the interactive system, which is much faster if you compare to the batch system, but in terms of the real-time system, it's much slower. And I think after this is a real-time, so it's slower than a real-time system. Introduced to the provide fast turnaround when debugging process. So time sharing software developed for the operating system. So this is an example of interactive system that we have previously. Okay, IBM mainframe, no need for us to explore more because this one we have gone through together. Similar also in your COE subject. Now, after we have the interactive system, we move to the real-time system, or we can call as RTOS. Reliability is the key for this system, real-time system, which is it is much fast and time limit sensitive. So this is the example used in a critical environment, example of like space flight, airport traffic control, high-speed aircraft, industrial processes, sophisticated medical equipment, distributions of electrical, phone switching, and many others you can list here. So must be 100% responsive and also 100% response in the time. After we have this, might be we think, oh, this is the much more perfect system that available, but yet not. It is having a hybrid system. When we talk about hybrid, we know that it is a combination of two systems, which is the combine the batch and interactive system. So go back to this, it combine batch and also interactive system. It called as a hybrid system. Appear to be interactive, which because you have the interactive element here, use it as a system which is fast response. Accept and run bash program. in the background condition when interactive load is light. So take advantage of 3 time between high-low demand usage. And many large computers currently are using the hybrid system. And we have embedded system. Currently, we heard about embedded system many time, especially in terms of various fields, isn't it? So embedded system, a computer placed inside other product, add features and capabilities. It have a advantage on this, and operating system require perform specific set of program, non-interchangeables among system, small kernel and flexibilities function capabilities. And I think this one is okay, the last topic. This is the last subtopic for you, which is computing environments. We will look into 4, which is traditional computing, mobile computing, distributed system, and lastly, virtualization. Let's take a look into one by one, which is first on the traditional computing. What is traditional computing? It is a standalone general purpose of machines, but blurred as a more system interconnect with others, especially example of your internet. In terms of your traditional computing, portal provide web access to the internal system also. A network computer is small. It's like a web terminal only. Mobile computer interact via wireless computer after you have you're going to connect to the mobile computing later on. Networking become ubiquitous. Even home system use firewall to protect home computer from internet attack. Computing environments, which is your mobile computing, normally using the handheld smartphone, your phone, tablet, and each. What is the function difference between them and traditional laptop? Extra features, more OS features. So allow new type of apps like augmented reality, AR, and then you normally use the IEEE 802.11 wireless or cellular data network for the connectivity. Normally, mobile computing are always using the Apple iOS or a Google Android. And third one, this one last time I also have been touched a little bit in your class when we related to the distributed computing. We are dealing with the network stuff, and there are several type of network. We have LAN, WAN, MAN, wireless LAN, PAN, and last time we have learned on the SAN. So look back in your previous slide, we have a SAN network. Network computing network operating system provide features to allow sharing data between systems across the network. And lastly, in terms of your virtualization, this computing allow operating system to run application within other OS. Okay, normally you're going to use the emulation and virtualization in your virtualization network computing. So example is using your virtual machine manager. Virtualization can have on top of your laptop and your desktop itself. So it's allow user to install multiple operating in one devices. Multiple operating, you can see here, maybe you can have Mac OS and also Windows in one devices. So that is in terms of the visualization computing. How the hierarchy of your structure, you can see this is example of one, and here you can have like several kernel. Virtual machine, you have 3 here. I think the most we can use is like 2, but yeah, it can be expand depending on how much capabilities our computer can be. So this is the example single OS, or if we have a multiple OS in our devices or gadget or even our computer. Okay, I guess that's all for our theory in our module 1. Later we're going to meet in our class, and if you have any question you can ask me through in our class, and we're going to move to our module 2. Okay, take care. Bye bye.